Welcome to Hartman Math. This is lesson 5.1, our introduction to inverse functions. So we're going to try to conceptualize what the idea is first. So it says imagine that you're watching a YouTube video. In the video you see Jimmy. I will be playing the part of Jimmy. Open a door, walk in the room, take off his jacket, and turn on the television. So we'll take a look at that. So we open the door, walk in, take off the jacket, and turn on the television. Now we're going to wonder what would happen if everything happened in reverse. So all that's happened, now we're just going to reverse it. So we're going to turn off the television. Put on the jacket. Walks back out the door. And closes it. That's the reverse of everything that happens. And that's really what our inverse functions are about. It's undoing the original situation. So let's take a look at our function f of x equals 3 times x squared plus 5. If we were going to substitute in a number, like trying to evaluate, well, what's f of 10? What would happen to the 10? What would happen first? So if we do f of 10, and we substitute in and replace, plug in a 10, according to the order of operations, the first thing that happens is our number 10, it gets squared. Then, once we squared the 10, maybe we have 100 at that point. Then we multiply by the 3. Last, we add the 5. So what if we reverse that all? What's happening? What happens first? To reverse it, completely reverse it, we want to undo. So we'll start at the bottom. How do we undo adding 5? We're going to subtract the 5. How do we undo multiplying by 3? We divide the 3. How do we undo squaring? This takes us back to Unit 4. We square root it. So that takes us to what the inverse function would actually look like. And this is the proper notation for inverse function. It's f, and it looks like an exponent of -1, but f is not a variable. It has no value, so it's just notation, and it means f inverse of x, or the inverse of f of x. So what happened? We took our x, we're going to subtract 5, divide it by 3, square root the whole thing. Subtract 5, divide it by 3, square root the whole thing. That's our f inverse of x. Next, we're just going to play around with some functions. We have an f of x and g of x, a couple different situations. Following the directions, we're going to substitute in a couple different values. X equals 6 first. Substitute that into f of x. Whatever we get as an output, as an answer, we'll substitute that into g of x. See what happens. Based on those results, could we assume that f of x and g of x are inverses? So let's try with 6 first. So we're going to substitute in 6 and 6. So we should get 3 times 6 minus 5. And that comes out to be 13. We'll then take our output, 13, substitute that into g of x. So 3 times 13 plus 5. And that turns out to be 44. So originally we started with 6, we ended up with 44. Let's try part B. Let's try it with -2, same process. Plug it into f of x first, so 3 times -2 minus 5. And you get -11. Substitute that into g of x, 3 times -11 plus 5. -33 plus 5 is -28. We started with -2, we ended with -28. Not sure I see anything special happening. Let's hold off on this question. Let's explore these f of x and g of x, see what happens. So we've got x equals 6. So f of 6 is equal to square root of 6 plus 3. 6 plus 3 is 9. The square root of 9 is 3. 3 is our output. Now it says substitute that into g of x. So g of 3 is 3 squared minus 3. 9 minus 3 is 6. We originally started with 6, and we ended with 6. Let's try the -2. So f of -2 is square root -2 plus 3. -2 plus 3 is 1. Square root that, also 1. We get an output of 1. Now let's do g of 1, that output. G of 1 is 1 squared minus 3. So 1 minus 3 is -2. We started with -2. We ended with -2. Are these inverses? This f of x and g of x? Yes, they are. Because the g of x undid the f of x. Whatever f of x got us to, g of x brought us right back where we started with a 6, or here with a -2. Over here, we started with 6, ended with 44. Nothing special. We started with -2, ended with -28. Nothing special. These are not inverses. G did not undo f. That one's a no. So how do we come up with these functions? That's what's next. To find an inverse algebraically, we're going to take these 4 steps. Number 1, rewrite it out of function notation into a y equals equation. Number 2, switch the x and the y. Number 3, solve for y. Once you got that done, number 4, write it back into function notation. But instead of f of x, we're writing to indicate that it's an inverse, f inverse of x. Let's practice on this one. We've got a function h of x is equal to 2x plus 9. Step number 1 says rewrite it as y equals. So y equals 2x plus 9. Step 2 says switch the x and the y. So this we're going to rewrite as x. This we're going to rewrite as y. We've got to solve for y. Y is now on the right side, so let's kind of focus on the right side. We would undo the plus 9 first, so we'll go subtract 9 on both sides. And lastly, we need to get rid of the 2, undo the multiplication. We're going to divide both sides by 2. Last step, rewrite it as inverse notation. We are talking about h of x. So we will say h inverse of x is that. All right, test it. Let's see if it works. Okay, let's just pick an x at random, plug it in here, see what happens. I don't know. Let's try a 3. 2 times 3 is 6. plus 9 is 15. So that's our output, 15. Now let's plug that into the inverse that we just found, see what happens. 15 minus 9 is 6. Divided by 2 takes us back to the 3. Remember, we started with 3, took us back to 3. I think they're inverses. All right, a couple more to try. We got a P of X, we got a C of X. If you want to, you can pause it here, work through them, see how it goes, or we can just roll through together. P of X is a little bit interesting. It does say something about X. We're not going to quite really worry about that quite yet. In a future lesson, though, we're going to discuss why this kind of has to happen here. It's called a domain restriction. Well, let's focus on our process. Let's write it as y equals. Step 2, let's switch x and y. Let's solve for y. As we solve by undoing the opposite, we kind of work reverse order of operations. We typically, unless parentheses are involved, want to undo addition and subtraction first. So we're going to undo the minus 7. We'll add 7 to both sides. Then we want to undo any multiplication or division, so undo the 2. So we're going to divide both sides by 2. And lastly, we would square root both sides to undo the squaring. So we'll square root both sides. Ordinarily, when we square root both sides, we do plus or minus, have the plus or minus, because we get 2 answers. But because of our domain restriction, this essentially being the positive side, we're going to pick the positive of those. Last step, let's rewrite it as P inverse of X is that. You can test it if you wanted to. All right, C of X, cube root. Let's start. Step 1, y equals. Step 2, switch the X and the Y. Step 3, let's solve for y. Can't get at the minus 4. It's buried inside the root, so we can't undo that first. We're going to have to undo the root first. So to undo cube root, we are going to cube both sides. So x to the third is equal to, when we cube this side, we just get the radicand inside the y minus 4. Now we can get rid of the minus 4. We're going to add 4 to both sides. We got y by itself. We've accomplished step 3. We finished this very quickly. Step 4, rewrite it into function notation. C inverse of x is x cubed plus 4. That's it for today. See you next time.